Okay, my dear students, uh, welcome to YouTube Sanketika channel. So, it's my pleasure to start my lecture on estimation of forging cost. Basically, it is a fifth semester subject, but in the slide show it is showing sixth semester. So, it is pleasure to start my lecture with this brief introduction. So, actually, the objective of this slideshow is to discuss flash losses, scale losses. I mean, what are the different losses which will occur in forging? This is one of the manufacturing method in mechanical side. So, in the forging, you have different losses that you can see on the screen: scale losses, flash losses, tongue hole losses, sprue losses, and finally you have shear losses. So briefly we will go through this all the losses, so just briefly. So then we will go to the problems directly. So because we need all these losses, we are going to calculate these losses while calculating the cost of the forging. So let us start with the scale loss. So basically scale losses means whenever you heat a material. So in the red hot state, every material will be in in active state. So it is an active state means it is more prone or very active to react with the oxygen in the atmosphere. So when the material reacts with the oxygen, so oxide will form. Suppose if you heat ferrous based material, so ferrous oxide will form. So this ferrous oxide will, when you hammer or when you are doing operation on the ferrous based material, so that will drop from the material. That means the scale will come out. That means the material will come out in the form of scales. So normally this will be a loss when you heat a material. So this needs to be considered while calculating the forging cost. This is one of the important loss while calculating the forging cost. We need to consider, even in some problems, scale losses will be considered as percentage. So normally in our syllabus, scale losses will be considered at a certain percentage. Like if the material cost is, if the material weight is, or if the material volume is so and so percentage, so and so value, so based on that value, the percentage, if the scale losses are to be considered as 5%, so you calculate the 5% on the volume that you are calculated. So as you can see here, so in our calculations, so you can consider this 7.5% of net weight or volume if the forging weight is 5 kgs. If the forging weight is 5 kgs, we need to consider 7% as the net weight. Okay, in 5 kgs, so under 5 kgs, you can consider 7.5% as scale loss. If the forging weight is in between 5 to 12.5 kgs, so then you can consider 6%. So 7.5 if it is 5 kgs below, and 5 to, if the forging weight is 5 to 12.5 kgs, so you can consider 6%. So the loss which is above 5% is normally considerable. So now in this case 7.5 and 6% is very, we need to consider as per our syllabus. Then when you come to the flash loss, so flash is just like when you place a hot material, or when a material is in red hot state, if you place in the cavity of the dies, in between the two dies, so when you apply the pressure, so the billet will extrude from the meeting parts of the dies. So that means in the in the in the machine foundry process, So the two dice will be, the red hot material will be placed in the cavity of the two dice when you apply the pressure. So normally the material which is in plastic state will come out from the meeting parts of the two dice. So normally this will be considered as 20 mm wide or 2 centimeter wide. That means the material will project on the perimeter of the object, that is with a width of 20 mm and the thickness is 3 mm. So 20 mm width and 3 mm thickness will project on the perimeter of the object if it is a machine forging. So then you come out, so suppose if you have a square type of object, then four sides, square must consist of four sides. So four sides, assume that the side of the square is A. So then 4 into A will be the circumference. Suppose if you are calculating for the other cross sectional area, you have to calculate the circumference, then you calculate the weight of the loss, length into volume will give you the loss. You calculate the volume with the length of the length, means here it is a perimeter, then width and thickness will give you the volume. So then you can calculate the weight because you know the density. If you multiply with the density, so you calculate the volume, then you multiply with the density, you will get the loss in terms of kgs. So now you can see here the circumference, that means it's the length 20 mm wide, then 3 mm thickness, then it is the density. So if you multiply with the volume with the density, you will get the weight in kgs. So now you come to the tongue hole losses. So normally this tongue hole loss is the loss whenever you are trying to hold the workpiece with the help of a tongue. So you must have some projection on the workpiece. So this is an extra length that needs to be provided on the workpiece to hold with the tongue. So tongue is just like a plier you are going to use to hold the workpiece. So how much length you are going to hold is the criteria here. How much length you are going to hold with the help of the tongue, or the projection of the workpiece that needs to be hold in the tongue will be the tongue hole loss. So in this case, about 20 to 30 mm length or 2 to 3 centimeter length will be given as an extra length for all the workpieces to hold with the help of the tongue. So now you can see here, so you calculate the weight, so you have the extra length that can be around 20 to 30 millimeters, then you multiply the cross section, so length you multiply with the area, you will get the volume, then you multiply with the density, you will get the weight. But here the length means how much extra length you are providing on the workpiece to hold with the help of the tongue. So tongue is a device which is used to hold the workpiece in forging section. Okay, so normally the length is provided 20 to 30 millimeter extra length. 20 to 30 millimeter extra length is provided on the workpiece to hold with the tongue. You remember this figure, that's enough to you to calculate the tongue hole loss. You calculate the weight, then you calculate the volume, multiply with the density, you will get the weight in terms of kgs. So now you come to the sprue loss. So generally sprue is the portion of the metal between the length of the stock held in the tongue and the material in the die is called sprue. That means you are holding the workpiece with the help of the tongue. Okay, so then even though some material will not be considered, will not come inside the tongue, you have some extra material between the workpiece and as well as the tongue. So that is the material, or that loss we need to consider. That loss is nothing but sprue loss. I hope that you can understand. Sprue means the amount of material that is in between the die, okay, then the material in the tongue. The material between the tongue and the hole will be known as a sprue. Then you calculate the volume of that sprue is nothing but the sprue loss. You calculate that as a loss, the material between the die and the tongue. You calculate that volume, that is also a loss, that is termed as sprue loss. So normally this sprue loss is considered, even in some cases it is also referred from the standard textbook. So normally it is 7 to 7.5% of the net weight. You calculate the weight of the object, so final object that we need to forge. You calculate the final weight of the object, then you multiply with the percentage, you will get the net weight of the sprue loss, or net weight are the losses, or the sprue losses you can calculate by multiplying 0.07 or 0.075. So this is regarding the sprue loss. Then we move forward for the shear losses. So shear loss means, suppose if you are manufacturing or if you are forging more than one object, shear losses are considered whenever you are forging more than one object. In this case, you are going to cut the workpiece after the forging operation. So you are going to part of the object after the forging operation. You are going to cut the workpiece. That means blindly you can say that you are going to separate that object after all the forging operations are completed. That means you have to cut with the help of hacksaw or with the help of a chisel. Right? You have to use a chisel in this case. In the forging you have a chisel. So you with the help of chisel you have to part off. So during that some amount of material will be lost, so in the form of waste. So that material is normally taken as 5% of the net weight of the object. So after completing all the operations, or if you are forging more than, or if you are manufacturing more than one object, you need to part of that, you need to separate that object from the total bar. So during the separation some material will be wasted, so that material or that loss is nothing but shear loss. The shear loss is normally considered as 5% of net weight. Even in some cases shear loss will be considered as 2 centimeter thickness of the same diameter of the object that you are producing. But now on this slideshow you are observing that it is 5% of the net weight. If he is given as 2 centimeter, then it is okay. If nothing is specified, you can consider directly 5% of the net weight. Even by considering the 2 centimeter length also with the same diameter of the object, you can calculate the volume, then you multiply with the density, you will get the weight. So we will see all these losses with the examples. Now you just remind that, so you have shear loss, right? Then you have sprue loss, then you have stronghold loss, you have flash loss, then you have scale losses. These are very important losses, needs to be considered in forging operation. So let us come back to the examples. So let us start with an example. So it is a simple example. I think this example is going to consider all the losses. So scale losses, flash losses, sprue losses, stronghold losses, all these will be considered in this example. Because so now just you go through this problem, find the forging losses and calculate the gross weight of the material required for preparation of given component as shown in figure. Assume the density of the material as 7.88 grams per cc. If the density of the material in the problem is not given, normally you can take it as 8 grams per cc, but it is fortunate that in this problem is given 7.88 grams per cc. So cc means cubic centimeters. Even you can convert this into kgs per cubic meters also. So here the density is given in cubic centimeters. So if the dimensions are given in millimeters, so while calculating the volume you can convert these values into centimeters, you calculate the volume. Otherwise you calculate the volume directly in terms of millimeters, cubic millimeters. Finally you convert that into cubic centimeters. So everything is okay, but you should be careful while considering the units. So now you can see this figure. So this is exactly the object that we need to forge. So it is a single object, right? So find the forging losses, calculate the forging weight. So it is a single object. So density is given. So all the dimensions are in millimeters. So now you can see here, it is a circular type of object. I mean, it is circular in its cross section, because here is mentioned it is a diameter. That means it is, so the for a length of 10 millimeters it is having 30 mm diameter. For a length of 20 millimeter, so its diameter is 20 millimeters. For a length of 30 mm, its diameter is 10 millimeters. So I think this is very simple. It is just like a cylinder. You have 3 cylinders here for a length of 10, 20 and 30, 30, 20 and 10 diameters respectively. So you consider this as, you divide this object into 3 segments. So this is segment A, segment B and segment C are 1, 2, 3. So that is up to you. Either it can be ABC or 1, 2, 3. So now you can divide this object into 3 segments. So let us see. I think he is also divided this into 3 segments. So the first loss is a scale loss. Okay. So you calculate the net volume of the component first. So forget about the scale loss that is written here. You calculate the net volume of the component first. So it is obvious that it is cross section is circular. So then the volume of the circular cylinder volume is pi by 4 d square into L. You have 3 segments here. So pi by 4 d1 square L1. So is taken pi by 4 common. So d1 square L1, d2 square L2 plus d3 square L3. You have 3 segments here. So A, B, C. So I think it is, the first diameter is 30, its length is 10. Now you can see here, this is cross section A. The second section diameter is 20, its length is 20. So 20 square into 20. Then the third section diameter is 10, its length is 30. So he kept all the dimensions in millimeter itself. Remember, be careful while substituting the values. So in this problem he kept all the values as it is. In the millimeters he substituted. So if you calculate this, you will get the final volume is 15.7 into 10 cubic millimeters. So now he is converting this into cubic centimeters. So instead of converting all the values centimeters here, so he is calculating all the values, he is keeping all the values in the millimeters. So after calculating the volume of the component, final volume of the component, he has converted this volume into cubic centimeters. So initially this is 15.7 into 10 to the power of 3 cubic millimeters. He's converted this into cubic centimeters. So now you multiply this with the 10 to the power of minus 3. So you will get the 15.7 cubic centimeters. So this will be the final volume. So now our objective is to calculate the losses. So the first loss is, so he is calculating the net weight. So you have volume 15.7, then density is 7.88. So but it is okay. So you are getting this into the grams, because 7.88 is in grams, right? So now he is dividing this by 1000 to convert grams into kgs. So 15.77 is the volume. He is multiplying that with the density 7.88, that is grams in grams per cc. So this value is in grams per cc, 7.88 grams per cc, and it is volume is in cubic centimeter. Then it is okay, you are getting. So without this 1000 you will get the value, you will get the net weight in grams. So you divide this by 1000, you will get, I mean you are converting by dividing this entire grams divided by 1000, means you are converting that into kgs. So 0.124 will be the value. So this is the kgs. So can you convert this into the grams? Then it will be 124 grams. So he is divided, he is converted. So it is fortunate that, so our value is 0.124 kgs. So now you come back to the losses that we need to consider. The scale loss is equal to, we have seen in the previous slides that the scale loss is normally 7% of the net weight. 7% of the net weight. So if he is given this value, you consider in the problem, if he specifies that the scale loss is 7%, you consider as 7%. So nothing is given in our problem, also nothing is given. So you consider 7%. If he specifies its value is 6%, you consider as 6%. If nothing is specified, you take 7% as the scale loss, 7% of the net weight as the scale loss. So now you multiply this. So 7% 0.07, you will get 0.0087 kgs. So this is a scale loss. Then you come to the flash losses. We have seen that, right? So 3 mm thickness with for a length of around the perimeter. So a fin will be projected. You can call it as a fin. So where the two dice will meet, the billet will project for a length of perimeter. Around its perimeter, it will be projected as a fin for a width of 20 mm and for a thickness of 3 millimeters. So to calculate the flash loss, you need to calculate the perimeter of the object first. So that means that will become the length of the flash. You calculate the length of the flash. That length will become, that perimeter or that length will be useful to calculate the volume of the flash. So perimeter will become the length to calculate the flash loss. So now you come here. So this will be your circumference. If it is circular in its cross section, it can be a circumference or it can be a perimeter. So now in this case you have the 20 mm width and thickness is 3 millimeter, and you calculate the length, circumference or perimeter of the die or the object, because object will be placed in the die, so that around the perimeter or around the circumference of the object, the material will be projected for a width of 20 mm with 3 mm thickness. So now you calculate the circumference of the object. Go back to the figure. So I am going back to the figure. So now you see here, this is exactly the object that we need to forge. So exactly you draw a line around the circumference of this object, around the perimeter of this object. So you have 2 times 10, right? So front side and back side 10, 10 front side and 10 back side. Then you have 20 front side, 20 back side, 10 front side, right, for a length of 30, for a length of 20. Okay, 20 20, 30 30, okay, then 10 10. So now you calculate, so now you are calculated the length of the fin on the circular cross sections only. So this length and backside length, and the length on the 20 diameter cylinder, front side and back side, then length on the 10 diameter circular cross section, front side and back side. So now you have to calculate the length of the fin where these different diameters cross sections are meeting. So now 30 mm cross section and 20 mm cross section is meeting at this junction, right? So now there is certain gap, because ultimately this is 30 mm diameter and 20 mm diameter is meeting at this location. So there is certain difference in its diameter, so you need to consider that length also. So now you see here it is 30 mm and it is 20 mm. So now you can see here it is the total difference is 10. So 5 mm front side and 5 mm back side, you have that length. So otherwise you can directly take 10 mm length. So where these diameters, where these two cross sections are meeting, so the length of the fin is 10 mm. So now you come back to the cross sections, 20 mm diameter and 10 mm diameter, these two cross sections are meeting. So you have certain gap between these two cross sections, so that gap is also 20 mm length. So that will be 5 mm front side and 5 mm back side. You consider that length also. And similarly, you come back to the 30 mm cross section and 10 mm cross section. So the fin is also projected on the diameter of the, on 30 mm diameter and as well as 10 mm diameter, extreme left and extreme right. So that length is 30 mm and 10 mm. So let us try to calculate the first. So you come back to the length, so that he is calculating here. So now you can see here 230s. Okay, so then you come back to the so the total length of the fin is 180 mm. So this 180 mm is multiplied with 20 mm width and 3 mm thickness. So you will get this volume. You convert this into the cubic centimeter. Just you simply multiply with 10 to the power of minus 3. So 1 cubic millimeter is equal to 10 to the power of minus 3 cubic centimeters. So that you multiply with 10 to the power of minus 3, you can convert the value into cubic millimeters to cubic centimeters. So now you have obtained this volume. Okay, so you multiply this volume with the density, so you will get the weight of the flash loss. So this is very, very important. So while calculating the cost of the forging, flash loss needs to be considered, because it is also very high, 20 mm projection and 3 mm thickness around the circumference. So we need to consider it. Suppose if you are calculating the volume of the forging for one cast, one forge, you are calculating the cost of the one forge, then it is okay. Suppose if you are calculating the cost for 100 pieces or 200 objects or 1000 objects, so this value will be very high. So you obtain the weight. So then you come back to the tongue hole losses. You are aware that we are already discussed that tongue hole loss means the amount of material that will be held in the tongue. So while doing the operations. So this is normally 20 mm length or 2 centimeter projection will be held. We are assumed that 20 mm length will be considered to hold with the help of the tongue. 20 mm length with the same diameter, but in this case the diameter of the object is 20 mm. Okay, so for a length of 20 mm is holding for a length of 20 mm. Okay, you calculate the volume of the portion pi by 4 d square into L, and directly is multiplying with the density in grams per cc, and is multiplied this value to convert into cc. Okay, so in kgs divided by 1000 you will get 0.0469. so you calculate the volume, then you multiply with the density, you will get the kgs. So now you come back to the sprue losses. As in the sprue loss, nothing is specified. You are aware that sprue loss means the material between the dice and the tongue will also be a loss. That loss is termed as a sprue loss. The material which will be wasted during the forging operation in between the dice and the tongue is also a waste, that is a sprue. So normally this will be taken as 7%. Okay. So this 7% of the net weight of the object, 7% of the net weight of the object, net weight of the object is 0.124 kgs. So you multiply with 0.07, you will get the sprue losses. So now you see here, assume this, okay, sprue losses are 7%. Now the shear losses. You are aware that the shear losses may be considered as 5% of the net weight. So now you see here he is multiplying with the 5% with the net weight, so you will get the shear loss. So very simple, you add all the losses, add all those losses. So scale losses, flash losses, tongue hole losses, sprue losses and shear losses. You add all those values, you will get this value. So 0.126. So now you can see here the original object weight is 0.124, with the total losses are coming close to the object weight. Now you can see here the object weight is net weight of the object is 0.124. We are already calculated in the first step. You are already calculated all the losses. You are added all those losses here. So the value of the total or the gross losses weight is 0.126. You can observe here the weight of the object, net weight of the object, as well as the losses. Now you see here 0.124 is the net weight, then 0.126, you sum up all these values, the gross weight of each bolt or the object that we are considered is 0.125 kgs. So he is asked to calculate the weight only, right? Weight, but if he is given the cost per kg, you multiply this value with the cost 10 rupees per kg, you multiply that 10 rupees per kg here, you will get the cost of the forging, sorry. So but in this case he is asked to calculate the weight of the object by considering gross weight of the object by considering all the losses. Up to that only we are calculating. In the next slide show we will see how to calculate the cost of the forging. by considering these losses. So even though it is a very simple figure, we are calculated the volume, we are calculated the losses, then we are summed up those two values to get the gross weight. So I hope now you are familiar with the losses. So now come back to the other slideshow. So we will see the next example. So the objective of this slideshow is also to calculate the forging cost. So now come back to this. The objective of this slideshow is to estimate or to calculate the length of the object. Suppose length of the object here means you are calculating the weight of the object. In the previous slideshow, you are calculated the weight of the object. Suppose you are doing operations, you are producing more than one object, how much length of the raw material is required to produce more than one object. So here the length means the length of the object or the raw material required to produce number of objects, number of finished objects here. So now here the net weight, then gross weight. Gross weight means by adding the losses. So you will get, by adding losses to the net weight, you will get the gross weight. Then cost of the forging for a given component. By considering the, in this case the cost of the forging means you require some, you need to heat the material. So it also requires some cost. It also, it also requires, it is also expensive. So you need to spare some amount for purchasing coal, and you need to engage some human effort, you need to engage some people to carry the forging operations. So by considering those, so we will calculate the weight and gross weight, net weight, and the forging cost. So you have example here. So you have a steel stepped shaft here. Okay. So that is shown in figure 1. So we will see that the steel weight is 7.5 kgs. Steel weighs 7.5 kgs per cubic centimeters. That means it is a density. And the shaft is made by drop forging. That means it is a machine forging. So with this inputs, that means here it is a density. Okay. So if he is not given directly, you can consider this as 7.5 grams per cc. If he is not given, so in this case determine the gross weight of the shaft and weight of the direct material that will be charged. So we will see the figure first here. This is exactly the figure. It is also very simple. So he is calculating the volume of the shaft. So he is divided this into A, B, C, D sections. It is also, all portions are in circular cross section. He needs to mention this 20, 15, 15, 20 with the diameter symbol. So 20, 15, 20 and 15 diameter. You calculate the volumes like this, because this problem is also similar to the previous problem. So I will move faster than the previous problem. You calculate all the volumes of section A, B, C, D, pi by 4 d square into L by pi by 4 d square into L will be the volume. You calculate the net weight and you multiply with the density. In this case the density is 7.5 grams per cc. So divided by 1000 will give you the kgs. So you are obtained the net weight. Now you come back to the scale losses. So in this case it is 7.5% of the total weight. Even in some cases it is not given 7%. You can take 7%. That is also correct. So there is no much difference if it is 7% or 7.5%. Suppose if you are producing more than, if it is more than 100 products, it is not at all the difference. It doesn't matter, it can be 7 or 7.5 of the total weight. You multiply that, you will get the weight, then you calculate the length of the projected fin, so around the circumference of that previous object, and similarly 20 mm projection for a 3 mm thickness of the flash is 3 mm here, and it is 20 mm. You calculate. Now you can see here it is 3 mm and it is 20 mm projection. The length is 40, length into width into thickness, then you multiply with the density, you will get. Then the tongue hole loss. So tongue hole loss means, so 2 centimeter thickness or 20 mm length will be held with the help of tongue for a length of, for a diameter of, what is the diameter of this object here? It is maximum diameter, you can take it is 20 mm. So you consider the maximum diameter here. Maximum diameter it is 20. Now you see here pi by 4, 20 square into 20. So that gives you the volume. You multiply with the density, you will get the tongue hole loss. So now you come back to the sprue loss and shear losses. So sprue means the material held between the dice and the tongue. Normally it is 7.5% of the net weight. So here is an assumption, that is the sprue loss and the scale losses you can consider as 7.5. In that case also we are considered 7.5 scale losses. Even the sprue losses are also 7.5. So you assume these two values as 7.5. It is better than, because for remembering it is better figure 7.5, 7.5. So you calculate this weight, then you take the shear losses, it is 5%. In this case also, in the previous problem also it is 5%, then it is also 5%. You calculate the gross weight here. So net weight plus the losses, that means you add the losses to this net weight plus the losses, you will get the gross weight. Okay, so in this case also, so he is not, whether he is calculating, is given any cost of the cost of the material. In this case also is not given the cost of the material. Okay, so in example 1 we are not calculating the cost. So in this, determine the gross weight by considering all the losses, that's all. It is also simple problem. Okay, I am moving forward. So this is exactly the assignment. I am moving forward to the next problem than this. Okay, then from the current slide slow I am moving. So the objective of this is also same thing. So but in this case we will take a typical example than the previous examples. Typical example, it is an hexagonal headed bowl. Okay, so you go to the example 1 here in this slideshow. So just you see, estimate the length of the stock required to forge 100 mm 100 pieces here, 100 mild steel hexagonal headed bowls here. In this case, but in the previous examples we are calculated the volume and weight for one piece, but here it is, in this case, 100 mild steel hexagonal headed bowls. So you see here the diameter of the bar stock. So initially the diameter of the bar stock is 20 mm. By considering the 20 mm diameter, you have to manufacture the hexagonal headed bowls of 100 pieces as shown in figure. But in this case is not given the density. So it is a mild steel, or if it is a steel, you can consider density as 7.8 grams per cc. So now is also mentioning that neglect all losses except shear loss. Now you see here in this problem specifically he is saying that neglect all the losses except the shear loss. Now he is asking to calculate only the shear loss in this case. You can neglect all the losses. So this is exactly the figure. So the volume of the hexagonal headed bolt. So this is exactly the formula. So area of the hexagonal face, area of the hexagon is 3 square root 3 by 2 a square, where a is the side of the hexagon, side of the each face. Okay, so now the diameter of the bolt is 20 mm. So now you see here, length of the bolt is, length of the head is, length of the head is 100. Okay, so length of the head is 50. So diameter of the projection is 20 mm. Length is 120. It is just a cylinder. Now you have a direct formula here to calculate the area and volume. So the length of the head is 15. So length of the head is 15 here. This is the cross sectional area. 3 square root 3 by 2 into a square will be the cross sectional area of the hexagon. So cross sectional area you multiply with the length, so that is 15 here. So length of the hexagon here, hexagonal headed bolt is 15 here. Then now you come back here. So this is exactly the formula. So length is here. So a into h is 20 here. So you are obtained the volume of the head. Now you calculate the volume of the shank. It is just like a cylinder. So pi by 4 d square into L. So pi by 4 20 square into length is 100. You get the net volume of the bolt. So now you have calculated the net volume. Okay, you sum up the head and as well as the cylinder or the shank portion projected from the head. You will get the net volume. Now you consider, in this case he is asking us to calculate only the shear loss. You neglect all the losses. Wantedly is asking us to neglect all the losses. He is asking to calculate only the shear losses. So you are aware that the shear losses are 5% of the net volume or the net weight. You calculate the net volume. So here this is the net volume. You multiply this with the 1.05 will give you the total gross volume. Otherwise you can multiply with the 0.05. You calculate the shear loss individually, then you multiply that with the net volume, then you sum up that value to the net volume, you can get the gross volume. So instead of calculating the shear loss separately, you multiply that with the 1.05, you will get the gross volume. Okay, so this is the gross weight. Let L be the length of the bar stock. Okay, so you assume that as of now he is asking to calculate the length of the bar stock required. This is actually the required. Now you go back to the problem. So estimate the length of the stock required to produce 100 hexagonal headed bolts. 100 hexagonal headed bolts. So now you come back here. So our objective is to calculate the length of the bar required to manufacture 100 ms bolts. So you are aware that okay, so length will be the required object here. Then for a stock length of 20 mm diameter, so in the problem he specified that the 20 mm diameter stock is the required diameter. Then so now you see here, so suppose pi by 4 d square, you already calculated the gross volume here, 49,337 will be the gross volume. So volume is equal to pi by 4 d square into L. Okay, so will give you the length for one piece here. So this is area of cross section is multiplied with length. So this is the total volume for one piece or one object, and you are already calculated the volume required for one object. This is one way. Otherwise you multiply this total volume with the 100. Okay, and that is equal to pi by 4 20 square into L. So in that equation also the unknown is length. You multiply this with 100, equate this value to the pi by 4 d square into L. So where d is 20 is known to us, the unknown is only length, you calculate the length. But in this case, he is calculating the length of the bar stock required for one object. This is one way. And the other way also you can calculate, as I told just now. So the length of the stock required for 100 bolts is calculated the length of the bar stock required for 1 bolt. So that is 0.157 meters. He is multiplying this with 100, you will get this value. So that means 15.7 meters of the bar of diameter 20 mm is required. A bar of 20 mm diameter for a length of 15.7 meters is required to produce 100 mm bolts of the given size or with the given dimensions. This is exactly the concept here. But in this case also very simple, you are calculating the volume, right? But in this case you are not multiplying this with the density, right? He is not asked to calculate the weight, but in this case he is asked to calculate only the length, so that's why we don't require density in this case. Okay, we are calculated the length. You multiply this with 100 directly, then you equate this to pi by 4 d square into pi by 4 d square into L. In place of d you substitute 20, then you have length here, that is only unknown, you will get the same value. So that is another approach, and this is also same thing you will get. So this is also one problem. So we will go to the another slideshow. We will see the different problems. So then recap here. So we are already calculated. So the objective of this slideshow is to calculate the weight of the finished product in forging shop. Okay, so we will see here. So this is also one typical problem here. So please read this problem carefully. It is required to make a key of dimensions given in figure 1 below from a rod of 20 mm diameter. Calculate the length of the rod required in forging. In this case also we need to calculate the length. So length of 20 mm diameter rod required to forge this shape, to forge with these dimensions. Now you can see here. So this is a jib headed key we need to produce by taking 20 mm diameter. Now you can see here the maximum height of this jib headed key is 20 mm. So by taking 20 mm diameter, we need to produce jib headed key in or with the help of forging operation. You can observe all the dimensions here, but in this figure you looks like, but this portion, this 60 mm length looks like, I mean I'm saying regarding the geometry of this figure, but here this dimension is 20, here the height of this projected portion is 8, it is 20 and it is 8. So the cross section here it is 10 and it is 8. Be careful. Then so perpendicular to this the width is 10 mm, but here the height is 10, but here the height is 8. Okay, and similarly you see here the length is different, here this length is also different. For a trapezoidal cross section you have a formula to calculate the volume. So you assume this as A, and you assume this as B. A plus B by 2 into length into width. Okay. So A plus B by 2 into L into H will be the volume of trapezoidal cross section. So A is in trapezoidal cross section, and he's divided this object into three segments A, B, C, but B is in rectangular cross section. So this is exactly the 15, and this is also 15, because overall length is 15. You subtract 60, so here this length is 15. The height is also 15, and the width of the cross section and the width of the section B is also 10. So 15, 15, 10. But here you take this value, you calculate this value. It is also trapezoidal cross section. Okay. So you divide this into ABC cross section. Let us come to the calculation of the volume. So now you come to here, A plus B by 2, as I told you just now, A plus B by 2 into H into A plus B by 2 into length into width. So this is A, this is B by 2 into length is 60 here, and 10 will be the width. You calculate this, you will get, here these values are in millimeters. So you will get the volume of the part A or the section A or the portion A will be in cubic millimeters. Similarly, part B is a rectangular cross section, 15 into 15 into 10. You will get the cubic millimeters, volume in cubic millimeters. Similarly, you calculate the volume of the portion C, A plus B by 2. So now you will see here, A plus B by 2, here it is A plus B by 2 into, so the width is 10 and this height is H. So this will become length in this case, and this will become your width. So now you can see here, A plus B by 2 into 5. So that means here it is, length is 5 and its width is 10 here. So 625 will be the cubic millimeters. Then you sum up all those values, you will get the volume. Okay. So in forging key, only scale losses will occur. You assume that only scale losses are considered. In this case, he is considering only the scale losses. So assume the 7% of the scale losses. So you multiply this with the 0.07. So you will get the scale loss. You add this value, so add this loss to the net volume. So here the net volume is this, right? So 8275, you sum up this value here. Otherwise you can multiply 1.07, you will get the direct value 8855 here. So 8275 may be multiplied with 1.007, 1.007, you will get this value. So in this case, individually he calculated the scale loss, then he added this value to the net volume of the object, that is 8275, to get the gross volume. So it is also very simple. So now you calculate, so how much diameter of the bar stock is, because this 20 is already given to us in our problem. So how much length of the bar stock is required for a diameter of 20 mm. So this diameter is constant. This diameter is constant, is already specified in the problem. We cannot change this. We cannot change this value. We need to calculate only the length. You come back here. So pi by 4 d square into L. So okay, the volume formula is pi by 4 d square into L. So pi by 4. So pi by 4 d square. So area is pi by 4 d square into L is taken left side here. So volume by area will give you the length. Otherwise here left side you have length here. So volume divided by area will give you the length. So you are already obtained the gross volume and you divide that by the cross sectional area pi by 4 d square. So you will get the length. This is also very simple. This is also very simple. Similar to that. So now you come back to the other one. So okay. So from current slide. So I think I am skipping this problem also. So we are already solved number of problems. So like this I am also skipping this. I am also skipping this. Same I am skipping this. Okay. So very simple. I am skipping this. So then I am coming to the typical example. Now of course this is a typical example. So now you see here you have a figure here. So that is an Allen key. So that needs to be forged. So the density of the steel is given in this case as 7.9 grams per cubic centimeters. 7.9 grams per cc. So cubic centimeters or cc both are same, and cost of the steel is 15 rupees per kg. So as of now we are not calculated the cost. So in the previous examples we are calculated the losses, gross weight by considering all the losses. We are calculated the weight also, and we are calculated the length of the bar stock required if the object is more than 1. In this case also assume that 13% of the net weight is lost during the forging. So is directly given that 13% of the net weight is lost during forging. This is an additional scrap we need to consider. Apart from all the losses you can consider, you have to consider 13% extra as a loss in this case. Even in some problems he is specifying like this, unless he is given the extra loss, you are not supposed to consider this loss. But in this problem specifically he is mentioning that apart from all the losses you consider 13% losses extra. So now you go back to the figure, you consider this is exactly the figure, but in this figure this is exactly the quarter portion. So this turned portion, you have a shank here, hexagonal shank here, or else it is a bar, hexagonal bar. You have a hexagonal bar for a length of 25 mm. Here also you have a hexagonal cross section bar for a length of 25 mm. Okay. So you have a portion here, so that is a quarter portion. You have a circle. Okay, in a circle you know what is a quarter portion. For a length of quarter of a circle, so that is taking the round shape. So now he is also given the values. The labor cost is charged as 3 rupees per kg. 3 rupees per kg as labor charge. Labor charge means even in some times, okay, in the previous cases we are calculated only with respect to the material cost. So the losses that you are considered, flash loss, sprue loss, as well as the shear loss, and all those are the material losses, are the materials. With respect to the material you are calculated. But whereas suppose if you want to perform any operation in forging, suppose if you want to reduce the thickness, you need to engage a worker or you need to engage the labor. So that labor cost is 3 rupees per kg. With respect to the net weight, a company is paying labor cost. Suppose a worker is engaged to operate a product whose weight is 20 kgs. That means 3 should be multiplied with 20 to pay the labor. So per kg we need to pay 3 rupees per kg and overhead charges. You know what are the overhead charges, right? So suppose all these operations are performed in a shed, okay, and you require one office and all those losses, overhead charges. So that is also 5 rupees per kg. Okay, indirect losses, there are some supervisors needs to be engaged to check the quality. There are some office people to calculate the wages of the workers. So those charges will come under this overhead charges. You are familiar with this overhead charges. Then you estimate the cost of the key. Okay, estimate the cost of the key, only single key cost we need to calculate in this case. So now you see here, you come back to the figure actually. So you have a figure here. Suppose it is a bar bent in this section. So that bar is hexagon cross section. So that bar is hexagonates in its cross section. Okay. So its cross section is hexagon. Then it's throughout the length, you observe that throughout the length its cross section is same. Throughout the length, okay. So up to 25 millimeter length, and here also for a 25 millimeter length, and you have a bent portion here for a radius 50 millimeters. You have a bented portion here, that length is also, that cross section is also same. First you calculate the length of this key, then you multiply with cross sectional area, you will get the volume. So please do not confuse by looking into the shape, it is very simple. You should observe that, or you should notice that the cross section is uniform. If you are able to calculate the length of this object, our problem is very simple. You calculate the length, then you multiply with the area, you will get the volume of this Allen key. Okay. So now you see here how is calculating. So apart from the weight of the, you calculate the weight first. Okay. You calculate the weight, you multiply with the cost. Okay. Material cost is given. Okay. Whether is given any material cost here? Okay. So in the problem itself is given. It is a labor charge and it is the overhead charges. So first you calculate the length of the key. Mean length of the key, because you have a bent portion here, that's why he is mentioning this as a mean length. So as you can see here 25 mm and 25 mm, you sum up these values, then you have a bented portion here, that is exactly the quarter portion of a full circle. So what is the length of what is the circumference if it is a circular in its cross section is 2 pi r pi d. Okay, this is 2 pi r and pi d will be 2 pi r and pi d, 2 pi r and pi d, 2 pi r and pi d, 2 pi r and pi d. So I'm talking about this portion. I'm talking about this portion. Okay. So if it is a circle, so 2 pi r will be the circumference or the length of the perimeter. But here you have a quarter portion, so that means you divide this by 4. So that he is doing that here. Okay, now you see here 2 pi r divided by 4. So 25 and 25. So 2 pi r by 4 will give you the mean length. So now you multiply this length with cross sectional area. With cross sectional area. So we have a problem here. So we will restart this. So now you are aware that how to calculate the mean length of Allen key. So you have the projected portions 25, 25, and you have a quarter portion in a circle. So 2 pi r by 4. So I am closing this and I will restart this once again. Okay, I will restart this. So I will close this PPT. Okay, so I will restart this once again, so you don't have any objection here. So I'm restarting this. So then, so you come back here, now you can see here, so 25. So you will get the mean length of the key is 120.55. So now the task is calculating cross sectional area of the key. So to calculate the area of the cross section, you have a standard formula. So 3 cubic root 3 into a square whole by 2 will give you the cross sectional area of the key. Cubic root a square whole by 2, where a is the side of the hexagon. Now you see here 12 will be the side of the hexagon. So now the total cross sectional area is 374 cubic millimeters. So now you multiply this length with the cross sectional area, you will get, so now you have this value is in cubic millimeters, you convert this into cubic centimeters. So now the weight of the material, you can get volume multiply with the density, you will get the weight. So now you have weight here 0.38 kgs. So in this problem, you should note that in this problem he is asking to consider 13% of net weight as scrap. Okay, 13% net weight as scrap. So you multiply the net weight with 1.13, you will get the gross weight. So the gross weight is 0.43. So but in this case, the material cost, this is already specified in the problem, the material cost is 15 rupees per kg. You calculate the material cost per kg, it is 15 rupees, but whereas it is less than 1 kg, you multiply this 0.43 kgs. Okay, you multiply with the 15, you will get the material cost. But here the labor cost is 3 rupees per kg, but the gross weight here is 0.43. You multiply with 3, you will get the labor cost, this is, remember that it is for only one piece. Even in our problem also, he is asked to calculate the cost of one piece. So remember that he is asked to calculate cost of one piece. Okay, then you come back to the overhead cost. This is also specified in our problem. So that is 5 rupees per kg. So you multiply that, you will get the cost. So the total cost of the key is, you sum up all these values, okay, 6.45, 1.3, 2.15. So totally you will get 9.9 rupees per piece or for one object. Remember that this 13 percentage, okay, so instead of calculating all the forging losses in this problem, he told us to calculate 13 percentage directly. Okay, 13 percentage directly. So note that he is not calculated the losses here. Note that he is not calculated the losses here. Even in this problem also, nothing is specified. Okay, nothing is specified. He is asking us to calculate the cost of one piece or one object by considering 13 percentage additional scrap, 13 percentage additional waste on one object. So that he is not calculating any losses here. So directly is given 13 percentage, that's all. So this is very simple. So determine the length of 10 mm diameter cord required. So 2 pi r will be the diameter, inner diameter plus 2 into diameter by 2. This will be your mean diameter. Okay, so 5 plus 2 by 2, this is not required. This is very simple. So this is also very important problem. Estimate the length and weight of 1 centimeter diameter stock required to hand forge 200 mm rivets. In this case it is more than one object, 200 rivets of dimensions given in this figure. Assume the density of the material is 8 grams per cc. So now you can see here, so you have a spherical shaped head to a shank. Its diameter is 1 centimeter, its length is 2.5 centimeter. Assume that all the dimensions are in centimeters. So now you see here, it is a draw forged one. Remember, if it is a draw forged one, you need to consider only two losses, scale losses and shear losses. Scale losses and shear losses you can neglect. Draw forged means it is a hand forging. Okay, if it is a hand forging, in the problem if he specifies it is a draw forged and hand forged, you have to consider only scale loss and shear loss. So remaining losses you can neglect. Remember that if it is a hand forging or draw forging operation, you have to consider only two losses, those are scale loss and shear loss. Remaining losses you can neglect. So now you come to the problem. So you have a spherical portion here, spherical segment here. So the spherical segment volume can be calculated using this formula, pi by 6h square into 3d minus 2h. Pi by 6h square into 3d minus 2h. Now you come back to the figure. You come back to the figure. This is h and this is exactly your d. Okay, this is exactly your d. But d can be calculated. This is small d actually. This is small d. You have a capital D here actually. You have a capital D, that is exactly the diameter of the segment. This is exactly not the half portion of the sphere. Okay, this is not the half portion, it is only the segment of the sphere. Remember, the segment height is 0.7 here, the segment diameter is 0.9 here. Remember. Now to come back here, so now d is equal to 1.8 d. So d is equal to 1.8 d. So where small d is 1. Now you can see here where small d is 1. Small d is 1. Okay. You substitute the value here. You substitute the value here. So pi by 6 h square 3d minus 2h. So where capital D is equal to 1.8 into small d here. Okay. But here the small d is normally 1 or the object. Okay, so he is substituted very well, no issue at all. So 3d, capital D is 1.8, here h is 0.7. You substitute all the values, so you will get the volume. And similarly you have a cylindrical portion, that is pi by 4 d square, diameter is 1. He is calculating the volume of the object directly in centimeters. Remember, he is substituting all the values in centimeters. So finally you will get the volume. So finally you sum up these values, you will get the volume. This volume corresponds to only one object. This volume corresponds to only one object. Okay, this 3.31 corresponds to only one object. But in our problem, he is asked to calculate the volume of 200 rivets. Okay, or cost of the 200 rivets. So now you multiply that with the previous value 3.31 with 200, you will get 6.62. So now you consider the scale losses as 6% and shear losses as 5%. Okay, so scale loss 6%, even in sometimes he is assuming this as 7.5, that is also nothing wrong. Okay, so you can calculate, you can assume 6 or you can assume 7.5. So everything is correct. Okay, even 6 is correct, even 7 is correct. Then the shear loss is, it is constant, it is 5%. So you multiply this value, so shear scale loss is, you multiply this with the 0.06, you will get this. You multiply 662 with 0.05, you will get this. Okay, so you sum up these three values, you will get the final volume or the gross volume or the total volume required for one piece. This is for this is for 200 pieces. You are already multiplied with the 200. So then pi by 4 d square into L, okay, will give you the, you equate this final volume to the pi by 4 d square into L. So L you have here, so you will get the length. So length is equal to volume by area. Length is equal to volume by area. So the total length of the stock required is 936 centimeters. Okay, total length of the stock required. So this is also one typical problem in forging. Okay, so this is also a typical problem in the forging, so which is not covered in the textbooks. Okay, I hope this is also covered in textbooks of our curriculum. So diploma curriculum, this is covered, but I hope this Allen key is not covered. I hope this Allen key is not covered. So thank you very much. So with this we will close this session. Thank you very much for your patience. Okay, if you like this, you subscribe the channel. Okay, so Sanketika video. So thank you very much for your patience. So you have any doubts, and you can come with the doubts tomorrow, or you can contact me directly. So thank you very much. Okay, thank you guys.